Hi, in this video we will do some examples for laws of exponents. It will involve some evaluating exponential expression and simplifying. Okay, let us start with the first example, which has 6 parts. We have to evaluate these guys. So let's start with the first one, the third root of 125. Okay, so we first know that 125 is also third root means that the power is 1 over 3, and we also know that 125 is 5 to the power 3. And well, this is exponent of exponent, so you multiply them, you get 5 to the power 1, which is 5. 81 to the fourth root of 81, so 81 is 3 to the power 4, and this is 1/4. That gives us 3 to the power 4 over 4. Exponent of exponent, you multiply, so this is 3 to the power 1, which is 3. How about this one? Okay, so I will go a little bit different way here. So this is we can write it as this guy here, and we know that this is root 9 to the power 3. Root 9 is 3 to the power 3. This will give us 27. I'm just trying to use different laws in different directions. Okay, how about this one? First of all, there's a negative sign, so we can take that to the denominator. And then we have 16 is 2 to the power 4. And that will give us 2 to the power 4 over 4, which is 1 over 2. Well, you can go a little bit further. You can write it 0.5, but that's not very important step. This guy here, again, there is a negative, so we can take it down. And here we have a 2 to the power 3 to the power 2/3. Now this will give us 1. Exponent of exponent, you multiply the exponents. And that is 1 over 2, 6 over 3, which gives us 2 to the power 2. And this is 1 over 4, which is, well, again, this is the numerical computation, is not that important for us. In this part, well, we see that 27 itself, first exponent of exponent is this guy. And 27 itself can be written as 3 to the power 3. Then another exponent of exponent. And these two cancel, we get 3 to the power 2, which is 9. So those were just examples of computing exponential expressions. The second example will be on simplifying. Well, these are more like how exponential properties and other operations work together. Okay. First one, okay, we have the same base, so we can write one of the bases and add the exponents here, and then this gives us 5 minus 2 plus 3. This is 16 to the power 1 over 4. And again, this is 16 is 2 to the power 4 to the power 1 over 4. Exponent of exponent, you multiply the exponents. This will give us 2 to the power 1, which is 2. Here, in this case, we have root 3, root 12. So root 3 is 3 to the power half, and root 12 is 12 to the power half. When you multiply, they have same exponent. You can write one of the exponents and multiply the bases. So this will be 36 to the power half. 36 itself is 6 to the power 2, and this gives us 6 2 over 2, which is just 6. Well, you may remember these steps as this one, that when you have two radicals, they can be multiplied. So it will be like root 3 times 12, and this is root 36, and which is equal to 6. This is another way. What I wrote up there is more detailed version of what you can do alternatively down there. Okay. Here, I have an exponential expression with base 8, and down there's a 4. If you don't have same base or same exponent, you cannot do anything. But in this case, you see that we can turn 8 to 2 to the power 3 and 4 to 2 to the power 3. So to start with, we didn't have the same base, but doing this trick, we get same base in the numerator and denominator. This is 2 to the power 5, 2 to the power 2, and while use the rule that's supposed to be that. Okay, 2 to the power 3, and that is 8. Same tricks goes here. So first find all the write all the base such that those have the same base. Okay, then we have 2 to the power 3 over 4, and this is 2 to the power negative 3, and this is 2 to the power 5. Now apply the exponent law. So this is 2 to the power 3 over 4 plus negative 3, and then minus 5. That will give us 2 to the power, okay, this is negative 8, 32, and this will be negative 29 over 4. Yes. And this one, well, this is now general base. It will make the first thing is in the numerator we have product of two exponential expression with the same base, so we can add the exponents in the numerator. In the denominator we have exponent of exponents, so this can be product of the exponents. So this gives us b4 plus 2x, b2 minus 2x. Now you have two expressions divided, same base, so we subtract the exponents. And that gives us b to the power 2 plus 4x. For the last one, first thing is that the root can be written as the half exponents, and then in the numerator we have 5x plus 1 over a to the power 4 plus x. And this is a to the power 5x plus 2 over a to the 4 plus x, and then to the power half. This gives us a to the power 5x plus 2 minus 4 plus x to the power half, and that is a to the power, okay, 5x minus x is 4x, and 2 minus 4 is negative 2 to the power half. And then you divide these guys, so this is exponent of exponent is product of the exponents, and that gives us 2x minus 1, and that's what we were trying to see. So you have to be able to perform these kind of simplifications and complete or evaluate the exponential terms.